Hello. Today we will simplify the following expression, which contains logarithms. We assume that variable x is a real number. First, we recollect definition and main properties of a logarithm. Let a y equal log a of x. In this case, according to definition, x equal a to power y. Base number a must be positive and not equal 1. Argument x must be also positive. The properties of a logarithm, which we will use today, are the following. Quotient property, which provides a logarithm of fraction as difference of logarithms. Identity property, which tells us that log a of 1 equals 0 for any possible a. And the last property is the following one. Here x becomes base number and so cannot be equal 1. At this point, I would recommend to stop video, solve the problem yourself, and share your answer with us using comment section. When you return, we will continue to solve the problem together. Now we will find admissible values of x for our expression. Our expression is a fraction, so the denominator of this fraction has to be not equal to 0. It is possible only when both multipliers, which we see here, are not equal to 0. Let's start with the second one. It will be not equal to 0 only in the case where x over 3 not equal to 1. So x not equal to 3. We rewrite at this point here, and we will analyze the second multiplier. It must be not equal to 0. We will use here this property and rewrite this term in the following form, like here. Then we transform the left-hand side to more convenient form. This multiplier in the left-hand side not equal 0. So we analyze what we have here. For simplicity, we denote log x of 3 as y and rewrite in such form. This is a usual quadratic equation. We can find discriminant. Discriminant is equal -3. It is less than 0. So this equation has no roots. It means that expression in the brackets doesn't give us new restrictions for x, and all restrictions are here. Now is the right time to start simplification itself. What we should do? What do you think? You are right. We should transform all parts of this expression in some way and to reach a simplified form. We already found expression for this bracket. It is this one. Now let's consider the second term in denominator. We apply quotient property, and we have here log x of x minus log x of 3. Log x of x is 1, and we have here 1 minus log x of 3. What remains? Remains numerator. Let's transform numerator using a well-known formula of algebra. A here is 1, b is log x of 3, and we have here the following. And this is our numerator. Next step, to plug in all what we found here back to the original expression. So we put this expression instead of these brackets, this one here, and this one in numerator. And as a consequence, we will have new expression, this one. If we look carefully here, we see that this part is equal to this. We can cancel them because it is not equal 0, because x is not equal 3. And then we can cancel this expression and this one, because they never can be equal 0. This is previous, so this is this. And as a result, we have here very simple formula. Our expression is equal log x of 3. And we have these restrictions for x. Now let's rewrite this answer in the compact form. And our problem is solved. If you have another solution or if you have another answer, please share them with us in comments, and we will discuss them later. And finally, I would like to ask you to support Dr. B in his work on future videos. This support can be done with likes or dislikes, subscription for the channel, and positive or negative comments. Thank you for your help.